All right, welcome everyone to Module 7 of our Renewable Energy Training Program, where we're going to be talking about utility programs and on-site renewables. A quick recap of the overall series. So the purpose of this series is to arm all of you with the skills necessary to evaluate, set, and execute on a renewable energy procurement strategy. We're now in sort of phase 3 of this, where we have evaluated some goals, we've set a goal, and now we're working on executing on that goal. In today's module specifically, we're going to be talking about some utility renewable energy programs and additionally some on-site renewable energy programs. We're going to be talking about different kinds of utility programs, different kinds of on-site solar technologies, and what might be the best fit for your organization. Again, this is module 7. So in the previous module, we talked about energy attribute certificates, and we are progressing through the suite of renewable energy procurement options that may make up your overall renewable energy strategy. All right, so what are utility green power programs? There are a number of different types of utility power programs. They also are referred to differently in different regions. There's also just some different words to describe these things. So I'm going to be talking about green premiums. They can also be called green power programs or utility green programs. But the overarching idea behind these programs is it's a renewable energy offering developed and offered to you by your existing utility. Taking the first one, a green premium. So this is a product that your existing utility will create. They'll go out and they'll source renewable energy on your behalf. You sign up to the program, and then you are guaranteed to get those, the attributes associated with that renewable energy. And the way these programs work is the number of people who sign up for the program, the utility then has to go out and procure enough renewable energy to meet all of the demand for everyone who signs up to that program. So these are great. They're really easy to sign up to. You just contact your utility. There might be a bit of a cost premium to these, but they're widely available in North America and Europe, and they're starting to be more available in the rest of the world as well. The next one I want to talk about are green tariffs. So these are also offered by utilities, but they're a bit more bespoke, so to speak, and they typically involve a contract with a specific renewable energy resource. So these are typically reserved for larger renewable energy purchasers who are looking for a specific project to offtake a large volume of renewable energy. But without doing a lot of the legwork, and we're going to talk about PPAs in the next module, without doing a lot of that legwork, without doing any upfront capital investment. So these programs are offered to large energy buyers by certain utilities. There are also some regulatory requirements for these. And so they're not offered everywhere, but this is a good option if you are a large energy buyer. And if there is not a green premium or green power program available to you. For these, the best course of action is to do some research on your existing utility, try to see if there are any other organizations that have done green tariffs, and contact them directly to see what might be available.
Yeah, and I just want to add to that. I mean, some people may have experience with their own utility offering to you the ability to kind of procure renewable energy and increase that mix in your own electricity, and you might see that on your bill. So you might be familiar with that. And just to let the audience know as well, in case you missed the 2 prior modules, Elliot went into more detail about EACs, which are energy attribute certificates, and it's a way to sort of track who is procuring and owning the renewable energy or the zero carbon attribute of the electricity. And you can learn more about that in modules 6 and 5. So you think about that. And I think the other thing is just that the utility company will provide you as a company the information you need about how much renewable energy you procured, sort of as an official documentation that you can then use in your sort of carbon accounting needs, or if you're setting public goals to sort of prove that you're reaching those goals.
Yeah, great plug for the prior two modules on EACs. And then the last method I want to talk about are called community choice aggregation programs. So these are, these are local groups or local nonprofits that that take care of the energy sourcing on behalf of a smaller region. So they'll say, okay, we have the existing utility in place. We're not happy necessarily with the mix of power that is going into the standard delivery electricity product. We want to go out and contract for more renewable energy or different types of electricity. And so these groups will form. If you're within their region, you have the option, depending on your locality, the option to sign up to the community choice aggregation program. You still, your power is still delivered by the existing utility. They're still running the wires. They're making sure that power gets to you and there are no outages and such. But the sourcing of the energy, the contracts with the wind farms or the solar plants is taken care of by another group. That's the community choice aggregation group. So this example on the right here, this is from a community choice aggregation group in the Bay Area called Peninsula Clean Energy. Peninsula Clean Energy, they operate on the Pacific Gas and Electric. PG&E is the standard utility. And you can see in this graphic here, they're saying, okay, well, if you go with PG&E, it's about 30% renewable, the standard mix. But we offer two programs. There's a 50% renewable and 100% renewable program you can sign up to. These are also quite simple. You're just kind of switching who you're paying your bill to, but everything is kind of handled by the existing utilities. So these are great options. If some of the other options don't work for you, if you don't have the volume necessarily to go after a power purchase agreement, you don't have a rooftop to go after on-site solar, these are great options for you to, if these programs are available in your area. So the point of this map on the right here is to show that there are kind of complex regulatory frameworks around green tariffs and green premium offerings. And so the point is not to necessarily delve into this map, but just to demonstrate that depending on where you are, some of these programs may be available, some of them may not. And so the most important thing is to engage directly with your utility, explore what options are available to you, and be sure to ask the right questions. So be sure to know about green tariffs, ask about those. Be sure to know about community choice aggregation. You can ask about those. But the other point I wanted to drill home on this map is that there may not be options available to you in these, depending on where you are. So this is just an example from North America. You can see different states have different options available for green tariffs and green premium offerings. Go into this knowing that these programs are available, but they may, depending on exactly where your location is, you may not be able to contract these. So those were utility programs. The next type of procurement I wanted to talk about is on-site renewables. So on-site renewable energy, there's a lot of different kinds of projects. We talked about the types of technologies that are typically considered renewable energy. So that these are mirrored here. So you have your power from the sun. So this would be solar PV. PV stands for photovoltaic. These are the typical kinds of solar panels you'll see on people's roofs. You have solar thermal, which is capturing the heat warming up water and using it that way, or they have these molten salt technologies out in the desert that kind of heat up a substrate to a really high temperature, create steam and generate power. And then you have wind. So these are typically will be small turbines. Some of them may not look like a typical turbine. They might be a vertical spinning turbine. You have small scale hydro, you have small scale geothermal, you have bioenergy, biomass, and storage. Storage is kind of its own thing. Obviously, you can't generate power this way, but you can store renewable energy that you're generating yourself to use later.
Elliot, with that type of environment where you're feeding renewable energy into the grid, if for our cloud providers who are looking at running a whole data center, for example, on solar, there needs to be consideration into what the grid can handle and how far away you are from an access to the grid. Would that be a correct assumption?
Yeah, for large energy buyers and for large energy generators, if you're looking at a large scale on-site system, there will need to be a lot of communication with the utility to make sure that they can handle the excess power that you're generating. And whether it's grid connected or not, are conversations you will need to have with your utility.
Okay,
yeah.
Thanks.
I would also say that typical data centers, right, they're running in the megawatts. So 10, 20, 30 megawatts, even more if you're talking about the hyperscalers. And an on-site system may be, even a megawatt, right, takes a huge field of solar array. And so the likelihood that you're not going to be able to cover 100% of the data centers, or maybe even a fraction of the data center's power consumption with sort of on-site solar. So on-site solar may offset some minor fraction of the data center's consumption. And the idea there is that, and you may lease it from a company, you may actually own it, depending on how the financials play out. But in general, you're going to need a supplementary source, a fairly large supplementary source for external renewables. So while it can be a contributor, it's definitely not going to get you to probably more than 10% of the data center.
Yeah, I think it's really important to consider this in areas of the world where there isn't much choice potentially around renewable energy. You're absolutely right. I'm talking about a solar farm where you'd have acres of solar set up to power the data center, but also feed into the grid and take power from that. You'd need a significant estate of solar to run a whole data center on, for sure.
Sure. And then when a project developer is developing a project, one of the first things they do is figure, what is the size, where is it going to be sited? And one of the permitting processes, right, is to go in and get approval from the utility, from the local electrical grid operator. So that would be, say, CAISO, California Independent Systems Operator in California. And they sort of make the decision about, is there enough connective capacity? Do they have to build out new connective capacity? So generally, like if you look at the hyperscalers, what they're doing is they're contracting with a developer to go build, as you're saying, Guy, right, a solar field, generally far from where the data center is, but it would be on the same grid. And so what happens is that solar field will feed electrons into the grid, and those get all mixed around. This is where it gets a little confusing for people, right? Those electrons get all mixed around with all the other electrons that are being generated on the grid. But the idea is, generally the data center owner would contract for the size of an array that would be about equivalent to the amount of electrons that data center will be pulling off the grid in a year, as an example. And then, so it's not perfect, right? Because in the night that solar array is not shining or not running. And so the data center is actually pulling electrons off the grid that are not from that solar array. But the idea is, can we at least put the number of green electrons on the grid that data center is using? And Google, for example, is starting to match, so buying enough renewables on their grid to match hour by hour. So even when the sun's not shining, they've got solar, they've got wind going, or some other renewable source, so that every hour of the day, the amount of electricity they're using, there's some renewable energy generator going on the grid at that point in time So quite exciting. We think that's sort of like the bleeding edge right now in renewable energy procurement. So quite exciting.
Yeah.
Thanks, guys. Yeah, lots of exciting stuff here. But getting back to on-site renewable energy, here are some of the considerations that you are going to want to think through if you're thinking about an on-site system. So there's geography, obviously. You have to have the right facility. If you're looking at solar PV, you need to have the right rooftop or a nearby field or a carport you can put panels on. You need to think about sort of the orientation, right? Where is the sun shining in relation to your building? Are you being blocked by another large building or a mountain range or something like that? So, the specific geography of your site, you may have a lot of sunshine or a lot of wind, but the specific geography is also going to play a factor. The next one you want to think about, obviously, is climate, right? We're not getting a ton of solar power in Greenland, but we are in the desert of Arizona, for example. There are areas that get a lot of consistent wind or have a lot of geothermal activity underground. So these are considerations you want to explore. There are a small amount of desktop research. You can kind of figure out what is available in your region based on solar radiance levels, based on wind maps and whatnot. You can kind of do this analysis yourself pretty easily.
And even having said that, there are countries in Europe, right? There Germany is heavy solar. So even in areas where they're fairly far north and maybe sort of not a sunny climate, they're actually successfully deploying solar. So it's not a deal killer, your location. It can change the economics and how much you can generate, things like that.
Yeah. And then this last one, this isn't typically a huge factor for data center providers, but you can think about any operational byproduct of your services that could go into, for example, a biomass or bioenergy on-site system. Talked a little bit about storage earlier, so just wanted to highlight it here briefly. This graphic on the right shows all the different kinds of energy storage technologies. There's a lot of different options. These work basically to shift some of the load around. So if you have, Nicola mentioned that the sun only shines during the day, the wind only blows at certain times of the day. That may not necessarily match up exactly with when you use energy. So an on-site storage system can enable you to sort of flatten that out a bit. So you can, when the sun is shining, you can be powering your operations and you can be storing some excess energy into a battery or an on-site system. When the sun goes down, but you still need power, you can kind of drain that battery and sort of, be able to use the sun's rays even when the sun's not shining. There's also some benefits that utilities may provide you if you have a large on-site storage system. There are programs where utilities can basically utilize your storage capacity to offset, spikes in their demand. They can actually give you, a monetary benefit for that. So this actually, for large energy buyers like data centers, this can be a valuable tool. Also, you should note you don't actually even need an on-site renewable energy to benefit from storage. You can kind of you can utilize this type of thing just pulling excess power off the grid when it's cheaper and using it when the grid is more expensive. On-site storage should be considered whether or not you have renewable energy on site.
I think there's also a possible kind of point here, depending on what sort of storage you have, that batteries actually don't like being fully charged all the time, and they lose their ability to hold a charge. And by taking putting a load on the storage at a certain time of day and using that, and obviously not running it completely dry, but by using the battery, you actually prolong the life of your investment.
So back to Onsite Renewables, I just wanted to talk about the two types of ownership structures we can have for onsite systems. So there's the owned generation. So these are you own the system, you pay for the panels, you pay for installation. It's sort of all owned by your organization. You automatically have ownership over all the energy attribute certificates that are generated. So there's no issues about scope 2 accounting and that sort of thing. You all have direct control over that. On the flip side, there is an upfront capital investment, and there's ongoing system maintenance and ongoing costs associated with an owned facility. So you can think about what may be best for you. If you have an energy team on site already, a robust facilities team, maybe an owned generation model could work for you. But yeah, just wanted to highlight that there are some downsides to that. On the flip side, you can do what's called sort of an on-site power purchase agreement. So this is where someone else comes in, they buy the panels, they take care of installation. You simply act as the host. So you don't have a lot of those upfront capital costs. You don't have the ongoing system maintenance costs. Those are typically handled by the equipment owner. You're just kind of hosting it, but you're getting the benefits of the on-site power. The one thing is, depending on the contract that you sign, you may or may not actually retain the energy attribute certificates from the system. So that's something you want to make sure that you look into in any contracts that you sign for an on-site power purchase agreement. So these are great options if maybe you have a smaller facility, maybe you don't have a robust energy or facilities team, but you have some space available, you have a good roof, you have a good carport or something, and you want to make use of some of that with some on-site renewables. You can take advantage of on-site power purchase agreements. Here's just a little decision matrix. We're not going to go through this in detail. Basically, these are the kinds of questions you should be asking yourselves if you're exploring an on-site system. Asking questions about your site. Do you have? Is there a possibility for a capital expenditure? Things like this, and then you can kind of make a decision about what on-site system may be best for you. So this is a good resource. But we're not going to go into too much detail here because there's a lot of decision points and a lot of questions to ask along the way.
Yeah, and I would say if you don't have an energy team or even one that's familiar with renewable energy procurement, there are consulting firms out there that have been helping companies procure renewable energy and set a strategy and an execution strategy. So there's definitely help out there. In addition to the Clean Energy Buyers Alliance Association, that's a great place to find a community of buyers and also service providers like consultants, legal organizations that can help do the contracting, et cetera, and developers who do projects.
And you get a 6-month free trial.
Yes. And through VMware, you can get a 6-month free trial with the Clean Energy Buyers Association.
Great. So that wraps up our training on utility programs and on-site renewables. In the next module, we're going to be talking about the largest, most complex form of renewable energy procurement, power purchase agreements and virtual power purchase agreements. So stay tuned for that.